Good afternoon all. So we are dealing with redox reactions. And in redox reaction, we completed the classical concept of redox reaction yesterday. So while studying the classical concept, I have told that there are a lot of definitions or there are a lot of methods which we can define redox reactions. So out of that, we discussed few methods like in terms of hydrogen, in terms of oxygen, etc. So today we are moving on to the next definition or next type of redox reactions, which are redox reactions in terms of electron transfer reaction. So here we will be speaking about the electron transfer and how this electron transfer is affecting redox reaction. So it's a very important topic. Let's move on. So taking a reaction CuSO4 plus Zn. So zinc and copper sulfide reacts together to form zinc sulfate and copper. This is a very famous reaction and it's a redox reaction too. So in this, how we will understand it's a redox reaction or not. We don't have oxygen or hydrogen here, and we don't speak in terms of electronegativity or electropositivity here. Now what we are going to speak is about the electron transfer. So for that, first we are going to find out the electronic charges which are present in each of this. Electronic charges is very familiar to you from the basics, like from sodium chloride you are learning that sodium is having +1 charge, chlorine is having negative charge, all those you know. First we are going to find out the electronic charges on each of this. So if an element is standing in its native form like Cu here and zinc here, it's standing in its elemental form or native form. So when it is standing in an elemental form, the charge of it will be 0. So Cu also 0 only will be here. So if it is in the elemental form, it is 0 charge. So if we consider ZuSO4, SO4 we know it's a polyatomic ion and the charge of SO4 is 2 minus. So obviously to balance this 2 minus in SO4, Cu will have 2 plus charge. Right. So SO4 is 2 minus. So Cu will have 2 plus charge. So copper is staying happy with its positive charge. But suddenly zinc will come and zinc will give its 2 electrons to copper. So zinc was actually in 0 state. So from this state, zinc gave its negative charges to Cu. So 2 electrons are given to Cu and zinc becomes positive too. So we can think that zinc is having a bad habit, like the negative charge we have. So whatever negative zinc had, that is being transferred to Cu and Cu will accept the negative and becomes a 0 charge. So zinc lost its 2 electrons, which is the negative charge to Cu, and because accepting of negative charge, it lost its positive charge and become to a 0 state. And what happened to zinc? Zinc gave out its negative charge. So from 0 state, after giving out negative charge, it became positive. So we can think like this. So zinc was having a bad habit, okay. So zinc was having a bad habit or some negatives in him. So that's why he was acting 0. So when he given out his bad characters or negative charges to copper, copper was actually positive. But accepting the negative habits from zinc, it became 0. It lost its positive charge. So what happens to the character of copper by accepting the negative habits from zinc? So zinc is having a negative habit and accepting that negative habit, what happens to the character of copper? So the character of copper is reduced, right? So accepting a negative character or electrons or a negative thing, the copper itself or the nature of copper is getting reduced to 0. But in case of zinc, zinc gave out its bad habits. Zinc gave out its negatives and stayed positive. So that is called oxidation. Giving out its negative charges is oxidation and getting a negative charge, it is reduced. So you can remember like that, getting a bad habit or character will reduce. So getting a negative will reduce an atom. So reduction is getting negatives or accepting electrons. So oxidation is giving out electrons or giving out negative. And now, who is the person who reduced Cu? Cu is getting reduced. So who is the reason for the reduction, or who actually gave the bad characters to him? Zinc, right? So zinc is the one who reduced the Cu. So zinc is known as the reducing agent. Zinc is the one who reduced copper. So zinc is known as the reducing agent. And now the question is, who helped zinc? Zinc was helped by copper by accepting its electrons or negative charges. So copper was the one who helped zinc to become oxidized. So copper is the one who oxidized zinc. So that's why we tell it's an oxidizing agent. Copper is the oxidizing agent who oxidized the zinc. But actually it is getting reduced. Still, it helped in the oxidizing of zinc, so we tell it's as an oxidizing agent. We will see few more examples. So this is another reaction, and by the way, remember this: oxidation is loss of electron, reduction is gain of electrons, and oxidizing agent is the acceptor of electron, and reducing agent is the donor of electron. We will discuss that in this also. So in this case, we will see what is the charge of sodium. Sodium will have positive charge always. So sodium being positive, there are two sodiums. So two positive charges are there for Na2. And how many charges should be there for sulfur if it is 2 positive? Of course, it will be 2 negative. Right? To balance this, sulfur should have a 2 minus. But in this case, both are in native form, or both are in its own elemental form. So both of them will have 0. Right? Both of them were in the 0 form. So in this reaction, who do you think is the culprit? Culprit is sodium. Sodium was actually 0 and was transferred to positive. But sulfur was 0, but he got his negatives. So sodium gave out his negative charges to sulfur. So sodium gave his electrons to sulfur and became oxidized. So oxidation is process of loss of electron. So sodium lost his electron to sulfur. So sulfur is the one who accepted the negatives from sodium and became negative by itself. So sodium loses its 2 electrons and sulfur gains that 2 electrons from sodium. So here the one who got negative charge, or one who gained the negative character, is getting reduced. So as we told, reduction of character is for the one who accepted the negative charge, and he lost the negative charge and became positive. So he is getting oxidized. And who is the oxidizing agent here? The one who oxidizes, or one who helps oxidation. So sodium is getting oxidized. The one who is helping his oxidation is sulfur. So by accepting the electrons, sulfur is helping sodium to get oxidized. So sulfur is the oxidizing agent, and the one who helped sulfur to get reduced is sodium. So sodium is helping the reduction. So sodium is known as the reducing agent. The donor of electron is reducing agent, acceptor of electron is the oxidizing agent. We will see one more example. So here also we do have sodium. Sodium will be positive and chlorine will be negative in this case. So how it will be, or how oxidation and reduction we can represent here. So like that in the last case, sodium is the one who donates electrons or gives out electrons, or loss of electron is for sodium and becomes Na+. In case of chlorine, chlorine is accepting those 2 electrons from sodium and becoming minus. So 2 compounds are formed of NaCl, which balances the equation. So which is getting oxidized? So remember, gain of 2 electrons, whoever gains a negative charge will be reduced by its character. So chlorine is gaining electrons, so it is reduction or reducing. And sodium, it is losing electrons, losing negative and showing oxidation. And the oxidizing agent, the one with help oxidation, the one which helps oxidation is chlorine. So chlorine is helping sodium to get oxidized. So chlorine is the oxidizing agent, and the sodium which helps chlorine to get reduced, and sodium is the reducing agent here. And when we write an equation, we can write it as 2 parts. For better understanding, we can write a single reaction into 2 parts. So half reaction will be of sodium and the other half will be of chlorine. So let's see how it can be. So this is the half reaction. So 2 sodium becomes 2 Na plus. When it becomes Na plus, or there are 2 sodiums which are becoming Na plus. So what is the change here? It is giving out 2 electrons. So in the reactant part, sodium is staying in the native form, and in the product part it is getting a positive charge by giving out 2 electrons, and these electrons are accepted by chlorine to form Cl minus. So these 2 electrons are accepted by chlorine, or negative character is accepted by chlorine. So we can tell this part is the reduction part because it is accepting the negative part. So we can tell this as the reduction part as it is accepting negative, and this as the oxidation part as it is giving out the negative. And where there is oxidation, there we can see the reducing agent, and where there is reduction we can see the oxidizing agent there. So both of them are just opposite. We can actually find out the overall reaction from these half reactions. What we need to do is just the addition of these two. So we can cancel out this electrons and this electrons when we add this, because this part, the electrons are there in the product part and here it is in the reactant part. So in both sides if it is there, we can cancel them off. And finally the reaction will be in the product, in the reactant part we have 2 Na and Cl2, and in the product part we have 2 Na and 2 Cl. So when we sum it, we get 2 Na plus Cl2 gives 2 NaCl. So that's how we got the overall reaction. And these are the definitions which we have already told. Half reactions that involve gain of electrons are called reduction, and half reactions that involve loss of electrons are called oxidation. So gain of electrons, reduction; loss of electron, oxidation. You can remember it like that. So when you gain a negative character, your character will reduce, and when you lose a negative character, you will be oxidized. So this is the work for you. Justify the reaction as a redox change. So you need to write the half reactions and represent the oxidation and reduction process. So do the work, write the notes even by referring the textbook, and submit. Thank you.